This is part 3 of the Module 4 lecture. Now, in this, starting here, we're going to talk about the different probabilities of the different types of events that we will encounter. So the first one we're going to talk about is the probability of a complement event. Now, if you notice from the Venn diagram, between the elements in the event A and the elements in the complement of A, they cover the entire sample space together. Then we say that A and A complement are collectively exhaustive because they cover the entire sample space. Because of that, then we know that the probability of A complement plus the probability of A must be equal to 1 because they cover the entire sample space. And this is what we call the total probability. So we can use this expression to find, for example, if you're given the probability of a complement, then you can find the probability of A by just taking 1 minus the probability of the complement. Or if you're given the probability of A, which is a more common situation, and you are asked for the probability of the complement, then you will do 1 minus the probability of the event A to get the probability of the complement. Here's an example to see how it works. So in this case, a company surveyed 1,000 employees and their ages were recorded. So this table shows you the different age groups and how many employees are within each of those groups. Now, they're asking us to calculate the probability of randomly choosing an employee who is not between the ages of 35 and 34 years old. Well, looking at this, I think you intuitively see that if you wanted to find the probability of everyone else except those in this age group, then you will add all the numbers of the other groups, or the frequencies of all the other groups, and divide it by 1,000. That will give you this probability. You can also see intuitively that as well, I can subtract 366 from 1,000 and divide that difference by 1,000, and that will find that probability. Now, in the spirit of the probabilities, another way to do it, which is equivalent, is to say, okay, well, I want to calculate the probability of this group. So that's 366 over 1,000. That's the probability of an employee will be in the age group of 25 to 34, and that's 0.366. Well, now we use the complement rule because you want the probability of finding an employee that is not in this age group. And you use the complement, so do 1 minus 0.366 and you get 0.634. You will have found the same number using the intuitive approach that I pointed out in a minute ago. So one thing I wanted to remind you is that always include an explanation of your result. And this is because in the exam, I will be asking you to do this for every result that you obtain. So our final result here is 0.634. So you could say that the probability of selecting at random an employee that is not in the age group of 25 to 34 years old is 0.634 or 63.4%. Now, please note that if you would like to express the probability in percentage, make sure that you always put the percentage sign. Because if you say the probability is 63.4, well, that's not true because the probability is always between 0 and 1. And you can transform it into percentages, but you have to indicate that now you're referring to the probability in a percentage by adding the percentage sign. All right, please don't forget that. All right, so this is an example of how we can use the complement rule. And you will see we will use the complement rule quite often in subsequent chapters. All right, the next thing that I'd like to talk to you is this contingency table and the related probabilities. This section is pretty long, so I will first talk about contingency table and what it is, and then later we'll start talking about the different probability calculations where we rely on a contingency table to calculate. All right, so a contingency table, or the book calls them a two-way classification. It also is called a cross tabulation of frequencies. And in this case, a contingency table, well, in this example, a random sample of 1,501 male and female workers in the US were asked if they were stressed out in their work, and the results are shown like this. So we have the first variable, gender, with two classes, female and male, and we have the stress at work variable with classes yes and no. All right, let's look at what these numbers are. So this 282 says that there are 282 female workers that are stressed. And there are 480 female workers that are not stressed. And if you add these two quantities, you obtain 762, indicating that there are 662 female workers in the total number of 1,501 workers. If we look at this row, this number 244 implies that there are 244 males that are stressed and 495 male workers that are not stressed. If you sum these two numbers, 244 and 495, you obtain 739, indicating that there are 739 male workers in this sample of 1,501 workers. If you add 762 plus 739, you obtain 1,501. Now, if you look at the stressed work categories, so under the yes stress, or workers that are stressed, if you add the 282 and the 244 female and male workers, you obtain 526, indicating that there are 526 stress workers from the 1,501 workers that were surveyed. Now, if you add the 480 of females that are not stressed and the 495 males that are not stressed, then you find that there is 975 workers that are not stressed in their work out of the 1,501. So you can see that if you add 526 plus the 975, you get the 1,501 workers. So this is what characterizes a contingency table or a two-way classification. So in this other slide, I explain in detail what these things are. So these numbers here are called the joint frequencies, these four numbers here. These numbers here are called the row marginal frequencies, and these are called the column marginal frequencies. And this is the total number of observations. So another characteristic of these contingency tables is that you can transform these frequencies into relative frequencies and call these probabilities. So what you would do is divide each number by the total number of observations, and then you will find or you will obtain the relative frequencies or the probabilities. So in here, in this table, I'm showing that these numbers here, that you calculate them by dividing the frequencies by the total number of values to obtain the relative frequencies, we're going to call these the joint probabilities. And these are going to be the row marginal probabilities, and these are going to be called the column marginal probabilities, and this is the total probability. So this is the structure of a contingency table in terms of the probabilities and in terms of the frequencies. All right, I'm going to stop here. In the next segment, we're going to talk about more other probabilities that are calculated from contingency tables.